Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next of our What to Look For in the Night Sky series. We're talking about March 13th, 2023 this time around. So let's just start by taking a look at the board here. Let me get out of the way for you. One of the things that one of the things we work on with the astronomy students is geometrical imagination, spatial reasoning, thinking about how things fit together. So we'll look at how I put the board together for you today, and you see that everything's cramped way over here to the right, and everything's cramped way over here to the left, with the best part of the board, the middle, wide open space. So not the best planning, perhaps, but I'll let you draw your own conclusions about what you see. The thing that I work with the physics students with all the time is to tell them, if you want to unlock the secrets of the universe, if you want to figure out what's going on, you just got to be willing to go back and start over and do it again and again and again. You got to get every detail right, and you got to work hard, and you can't say, well, that's good enough, and just keep moving on. You got to really dig in. Which you see I didn't do here. I didn't erase the board and go back and fill in the middle of the board. So again, I'm going to let you draw your own conclusions. We've been talking about the planets, and we've been talking about the moon. So let's start with the moon. We're going to get away from that this week. We're going to get away from it slightly. We're still going to use these things to guide us to looking at some stuff. But let's talk about where the moon is. On the early morning of the 14th, so after midnight on the night of the 13th into the 14th, the moon is in Scorpius. And the moon is only, the moon's about 50-60% full, just over half full, and it's only a few degrees to the east of bright orange star Aries in Scorpius. So by all means, I recommend getting out there and looking at the moon here in Scorpius in the morning as we start the week. Now, by the end of the week, we get out here and we say on the 18th and into the 19th, so after midnight on the 18th. Now we're really talking about, we're not talking about 18th at all. We're talking about early morning on the 19th, very close to sunrise. The moon will have waned away to just over 5% full, probably about 7% full for me that morning. It depends on your time zone and where you are. If you're east of me, you've got a better chance at this than I do. So that's a very, very old moon fading into the sun. This region of the sky only rises about 45 minutes before sunrise. So it's going to be lost in the glow of the sun, but it's worth getting out there and trying. Get your binoculars out, look in the glow of the rising sun. But if you got to get an eastern horizon that's really good so you can see down low on the eastern horizon, and get out there and look to see if if you live in the eastern United States, as you live on the East Coast, then you've got a great eastern horizon. You've got a marine layer to worry about, but you've got a great eastern horizon to look at for the rising sun out there, and to see if you can find this very old moon sitting just below Saturn. We haven't talked about Saturn for a while. Here comes Saturn back for us to think about for all spring and summer and fall. So as we get a month from now, Saturn will be much easier to see than it is right now. But there it is in the morning sky, and see if you can pull just probably 5 degrees below Saturn is this old moon. See if you can see the old moon. See if you can see Saturn. If you see both of those things, let me know. It'll be a fabulous thing to go out and try to do. Okay, so that's what we've got. Now, also at the end of the week, this is all week, so you can do this. What we talked about last week is Venus and Jupiter. I hope you had a chance to see Venus and Jupiter doing their pairing in the sky, doing their little dance, and you see these things separating. And so by now, they were right on top of each other when last we talked. And by now, by the end of the week, Venus will be 17.5 degrees away from Jupiter. So they pulled, that's almost 2 fist widths at arm's length. So still a nice pairing in the sky that you can see up there, but it's not anywhere close like they were. You can see this vast difference. So at least one of them is moving pretty quickly against the background stars to do this kind of separation. And I'll give you a hint. It's not Jupiter. Anyway, you've got these things moving apart here. Now, last week, we used Venus to find a couple of different stars in Pisces, and we ended with Omicron Pisces, which is now back over here. It's past Omicron Pisces and moved on its way. And it's now we can use Venus to try to find some stars in Aries that aren't always that easy to find. So if you look up to the north of Venus and to the west of Venus just a little bit, about 10 degrees. So you got 17 degrees separating, 17.5 degrees separating Venus and Jupiter. Midweek it'd be 15 degrees or something like that. So about 2/3 of the separation from Venus to Jupiter, above Venus and off to the right, off to the west just a little bit, you're going to find Hamal. And Hamal is the alpha star in Aries. It's a good second magnitude star. So it's a star you should be able to see without any optical aid. If you got binoculars, it's always great. But you should be able to find that star, the brightest star in Aries. And then you drop 4 degrees, less than half the distance between Venus and Hamal, back down, and you find Saturn, which is also a bright star, 2.6 magnitude or something like that. So still a good bright star for you to be able to see. Hamal, if we look at Alan's star names like we like to do, these are of course both names that come to us from Arabic, as many of these names do. Al-Ras al-Hamal is the head of the goat, so that's what we have here. Al-Shadatan would be a sign, so the sign of the new year is what we're thinking about right here with Sheraton. Just below Sheraton, 1.5 degrees, so a couple of fingers or a finger below, is a fainter star, but still visible to you, I should think, and a 3rd magnitude star, Mesartim. So that's the alpha star, the beta star, and the gamma star in Aries. And so this is the pattern you want to recognize, the asterism of Aries you're looking for out there. Let Venus guide your way to it. Let Venus allow you to see that. Mesartim is a double star with the separation of the 2 stars. They're both bright white stars, and the separation is 8 arc seconds. And so that means it's pretty easy to see in a small telescope. So you got your binoculars. You can see a lot of beautiful stuff without any binoculars or anything here. But you got your binoculars. You can see some of this. You got your small telescope. That's a great target. Go up, learn the stars of Aries, find Mesartim, and get this double star and enjoy seeing those 2 stars together in the field of view. Alan's interesting to read in Alan's book about Mesartim, that name. A little less certain what that name is, and he went so far, we owe this name to Baer's star catalog, and he went so far as to say it was probably a mistake that Baer had in his catalog. So anyway, we live in a spiral galaxy. It's a beautiful spiral galaxy. We've talked about it before, the Milky Way and the disk of the spiral galaxy. There are a couple of spiral galaxies. There are 3 that we can find our way to here using Venus. You'll need binoculars or a telescope for this. And we'll start down here to say, okay, there's 17.5 degrees that separates Venus and Jupiter. If you turn a right angle down and to the left, you'll come in 16 degrees, about the same distance. So walk up from Jupiter to Venus, and then walk back down. Make a hard left turn, 90 degrees, walk back down about the same distance, and you get to M77. M77 is in Cetus, and M77 is a nice spiral galaxy. I think with a relatively small telescope, you should be able to pull M77 out. See it as a little slash of light. That's all you're going to see is this little slash of light. But one of the things we know about it is it has a very large redshift, and not by modern standards. Has a small redshift by modern standards. But when we were first trying to figure out what these were, whether these were clouds of gas, we called them spiral nebulae, whether the spiral nebulae were clouds of gas within our own Milky Way, or whether they were distant galaxies, which we now know them to be, we had a hard time. We were taking spectra of these things trying to figure out. And we measure redshift of spectrum, tells you how fast something's moving away from us. And things are moving away from us due to the expansion of the universe, space itself expanding, pushing these galaxies apart. And so we see all galaxies moving away from us. And to say almost all galaxies, the very nearby ones, gravity can win and can cause them to come toward us. But M77 was one of the first 2 that Vesto Slipher measured a very large redshift for, was able to measure a stellar spectrum. So it was one of the first few that were able to get a spectrum and show that it has a spectral characteristics of stars. And if it has the spectral characteristics of stars, that means it's probably made of stars. And if it's probably made of stars, then to look as faint as it does, it has to be really distant. And so that's when we started the tide started to turn for us to think, well, maybe these aren't clouds of gas within our own galaxy, the Milky Way. These are distant galaxies. So if you can find M77 and think about that history, that's a really fun thing to do. Now you go back up to Venus and you slide back up and then make a right turn, a 90-degree right turn, and go about half the distance across that you just went, a little less than half the distance. You get to M74, another big face-on spiral galaxy. Huge, huge galaxy, but man, is it faint. If you have a big pair of binoculars that gather a lot of light, that might be your best to see this. You try to look at it in a telescope and the surface brightness is so low, it just goes whoop, and it can be gone for you. So this is a good challenge for you if you want to try to observe M74 right there with a small telescope out in your backyard. And then we go on up. If we just continue on up this direction, we come to M33. And M33 is well on up there again, about this distance from Jupiter to Venus, back up this direction. M33 is a galaxy in Triangulum. This was in Pisces. And so we're in Triangulum up here, and M33 is a nearby, big but relatively low surface brightness galaxy too. It's one of these interesting objects, big old, looks like a full moon size of galaxies. So it's a big splash of light, but it's a faint splash of light. And it also, you point a telescope at it and it can go whoot and just disappear because of that surface brightness, how low that surface brightness is. But you can see it, I can see it, I've seen it with my naked eye. And so I remember a night camping where I was trying to sleep. It was cold and I was lying out in the sleeping bag trying to get a little bit of sleep. And I didn't have my glasses on. I can't see anything without my glasses, but I can collect light without my glasses. So I don't see anything distinctly, but I could gather light with the rods on the sides of my eye, and I can see faint fuzzy patches. And M33 is where I could see the Pleiades. Pleiades is on over here, and M31, the Andromeda galaxy, is on up here. Those are both brighter than M33, but I saw all three of those as fuzzy patches of light out of the sides of my eye there as I was lying on the ground trying to sleep. So it's possible to see M33 without any optical aid. I can attest to that because I've done it. I've done it more than that one time, but not very often. You gotta have a good dark sky. Up in the mountains I was at that time, for example. And so you gotta have a good dark sky, and you've gotta kind of use your averted vision. Use the sides of your eyes to gather that light in, and you have a chance to see it. We'll hold up to binoculars. So here's where your good pair of binoculars might help you out. But that's what I'm going to recommend, is go try to find those three galaxies, M77, M74, and M33. This whole region, Venus is pulled away so much that this whole region is up for a few hours after sunset now. So you have a chance for it to get dark. It's not ideal observing because you're looking toward the western horizon. You're looking through a lot of atmosphere. This whole thing would be better earlier in the year to check out these galaxies. But right now, using Venus as a guide, this is a pretty good thing to do. So find the stars of Aries. Check out these spiral galaxies that we have in the region. Appreciate how far Venus has moved from Jupiter. Check out the moon next to Aries. And then see if you can find it at the end of the week as it's below Saturn in the glow of the sunrise. So that's what we got. That's our week. It should be a great week. I hope you have a great week. And I hope you have some clear skies and you have a chance to get out and do some observing. And as always, thanks for watching, and we'll have something more for you next week.